Welcome, and thank you for clicking on this video. You might be looking at this equation, x equals x over 10, and thinking, is this a joke? This is elementary school math. It looks incredibly simple, right? A basic linear equation with one variable. You see equations like this, or even slightly more complex ones, listed in every algebra textbook. They are the building blocks of mathematics. Most people see this and immediately think they know the answer. They assume there must be a common, non-zero number that makes this work. But here's the fascinating part: this extremely simple-looking expression is actually a perfect trap. It's designed to exploit a very specific, and very common, error in mathematical reasoning. It's a mistake that even experienced students can make when they are rushing. By watching this video, you aren't just going to solve a trivial problem. You are going to learn how to avoid a critical mathematical fallacy that can derail complex engineering calculations or financial models. It's not about the answer, it's about the logical path we take to get there. Let's solve this equation, x equals x over 10, properly. We need to find the value of x that makes this mathematical statement true. When we see a fraction on one side, our natural algebraic instinct is often to eliminate it. The most common first thought people have is, okay, let's get rid of the x on the right side by dividing the entire equation by x. If we were allowed to do that, the equation would transform. We would have x divided by x on the left side, and x over 10, all divided by x, on the right side. On the left, x divided by x would simplify beautifully to 1. On the right, the x terms would cancel out, leaving us with 1 over 10. So, the equation would simplify to the statement, 1 equals 1/10. Now, ask yourself, is that a true statement? Is 1 equal to 0.1? Of course not. That is a contradiction. A fundamental, logical contradiction. And this is precisely where the trap has sprung. When a correct algebraic operation leads you to a false statement, it means one of two things. Either there is no solution, or you have performed an operation that was not allowed. In this case, it's the latter. Let's look at why that division was a mistake. In mathematics, you cannot divide by zero. Division by zero is undefined, it's a breakdown of the rules. The problem with dividing our equation by the variable x is that we do not know what value x has. If x happens to be 0, and we must assume it could be 0, then dividing by x is the same as dividing by 0. This is the crucial, inadmissible step. If you are finding this breakdown of common mathematical pitfalls helpful, please consider liking this video and subscribing to the channel for more clear explanations. Let's do it correctly now. The robust algebraic method, which avoids the division trap entirely, involves moving all the x terms to one side of the equation. We start with x equals x over 10. Instead of dividing, we subtract x over 10 from both sides. The equation becomes x minus x over 10 equals 0. To combine these terms, we need a common denominator. We rewrite x as 10x over 10. Now we have 10x over 10 minus 1x over 10 equals 0. We can now subtract the numerators. 10x minus 1x is 9x. So, the equation is now 9x over 10 equals 0. To isolate x, we can multiply both sides by 10, which gives us 9x equals 0 times 10. So 9x equals 0. Finally, we divide by 9. Since 0 divided by 9 is 0, we get the unique solution, x equals 0. And this makes perfect sense. If we plug it back into the original equation, 0 equals 0 over 10, which simplifies to 0 equals 0. This is a true statement. Our solution, x equals 0, is correct. To really cement this understanding, let's look at the problem from a different perspective, a graphical one. We can visualize any equation with two expressions by setting each side of the equation equal to a function and plotting them. Our original equation was x equals x over 10, which we can also write as x equals 1/10 of x. Let's define two functions. The first function will represent the left side. f of x equals x. This is the simplest linear function. On a coordinate system, it's a diagonal line passing directly through the origin, which is the point 0, 0, with a slope of exactly 1. Every point on this line has the same x and y coordinate. Now let's look at the second function, which represents the right side. G of x equals 1/10 of x. This is also a linear function, and it also passes through the origin, 0, 0. However, its slope is only 0.1, which is 1/10 as steep as the first line. On a graph, it's a very flat, almost horizontal line compared to f of x. We have shown algebraically that x equals 0 is the only number that satisfies this relationship, x equals x over 10. And visually, we've seen that these two lines intersect only once, at the origin. Both methods confirm the same result, proving that x must be 0. It wasn't about missing a solution, but avoiding a common error. If you enjoyed this logical journey from a simple question to a precise answer, remember to like and subscribe to support the channel. Thank you for watching, and see you in the next video.